Thanks everyone for joining this session. Hi, Hal. Good afternoon. We are going to present on NSO Generic MOP Configurator in this session. Right? It's basically a reusable NSO package to do the adhoc config governance. Right? Myself, Girisha Bukanakere. I am a software technical leader. Right? Belongs to CXPM Advanced Solution team. Right? So based out in Bangalore, I have been delivering NSO-based project from past 5 years with large SP customers like Telstra, Bharti, Optus. Quite recently, from last 12 months or so, I am actually working majorly on creating reusable solutions across 4G and 5G. Right, Karthik?
Yeah. Good afternoon, everyone, or good evening, everyone. Myself, Karthik Raja, and I'm from CX Centers India team. I'm currently working as a software architect for SP customers in Americas region, predominantly on TMO and Dish. My current role is to automate and orchestrate the deployment of 5G components spanning across from RAN to mobility core. Thank you.
Okay. With this, we start with an agenda. We are actually going through what is the problem we are trying to solve, what are the existing solution domain, and what are the limitations with this, right? And what is the history of config mop, and what exactly the generic config mop does, and what exactly the future roadmaps are. Finally, we have a demo, right? And you have a question and answers later. With that, this is try to creating an analogy, right? If you look at it, the top image is well orchestrated dance, right? It's actually it requires a lot of coordination between musicians, singers, and dancers, right? It requires a lot of considerations. It requires a lot of practice, right? If you want to change anything there, right, you need a lot of considerations. You have to regroup, you have to re-practice everything, and you have to present, right? Once everything is done, it's actually beast to watch, right? It's always be good to watch those kind of dances, right? Sometimes it's irrelevant, sometimes it's basically boring, right? It's well orchestrated one. As I am entering into the floor, I cannot participate in those dances because I don't know that dance form, right? It requires a lot of considerations and practice, right? Look at it. Basically, we have an ad hoc dance floor, right? Whichever music you are running, whether it's pop, jazz, or folk, anything, I have my own dance form, right? I will participate, right? I will bring in tomorrow some more friends, right? They will also participate. They have their own dance form. The floor is yours, right? That's quite exciting sometimes, right? That's what we are trying to create an analogy. Make your own dance with NSO, right? With that analogy, we are defining the problem, right? So as and when we onboard an NSO with any customer projects, right? Always ideal thing to do is to identify the service models, right? What exactly the standardization we can bring in, right? With those configurations, right? That's what it's ideal thing to do always, because that's where NSO brings the resiliency in the config management, right? We define the Yang model. We know what exactly we are applying into the network. That's where we spin off many instances of that kind, right? That's the ideal thing to do. There are areas wherein which is emerging mostly, right? 5G, 4G areas, right? Evolving every day, right? There are instances wherein which we couldn't able to define a standard service model over there, right? It requires a lot of ad hoc config updates using NSO, right? That's one of the requirement we have seen with some of the customer accounts, right? There are support needed to applying the configurations to single device, multiple devices with coordinated fashion and flexibility to do the partial rollback, full rollback, those kind of things, right? In this emerging technology areas, right? If you define a service model with the existing thing, only constant thing in that project is change every day, right? Because every day there will be updates to the config. You have to update your input model, Ang model, and you have to update your configurations in the XML templates as well. Basically, the service model is not well suited in certain conditions in those emerging technology areas, right? So we have existing solutions with NSO, right? There are a lot of built-in tools available already in NSO, right? It could be load native config devices, device load native config. You can actually feed in the CLI file automatically. It loads into the devices, right? It works seamlessly, right? We are also, we can use the relative load or load. It does the same thing as load native config. It actually relatively calculates the config path and basically applies it. It could be NSO CLI as well. Sometimes you can actually copy paste the configs and it works in the NSO CLI, right? Sometimes the Netconf devices, you have the configuration in the XML. You can also use the load merge utility. These are all the existing solutions available with NSO, right? What we are doing extra, right? What are all the limitations with this, right? That's what we are going to discuss first, right? So as and when you see the rollback IDs, the commit IDs which generated by NSO, mostly cryptic, it's just a number. It doesn't look like a correlation ID, and with that number, it's hard to remember, right? And there are no options to do the partial commits and the rollbacks, right? You have to apply all 5 files, and basically you have to say commit, and it applies to all the 5 files together to the devices, right? Likewise, if you want to do it individual commits and rollbacks, you have to, it generates the different commit IDs, right? There will be no correlations between them, right? Let's assume that we have an input file, right? The native config input file. I wanted to apply with slight modification to 10 different devices, right? We, for the load native config, we have to have those 10 files to apply, right? We have created like templatization variables, variabilization of those files, and we will keep the config metadata somewhere, and it substitutes it and basically applies it while runtime, right? Need not to do explicit check sync, right? Because we do everything check sync, connection check, sync from, right? And we'll also, the more important is order management. Let's assume that I wanted to push 10 files to 5 devices. I have my own order, right? This file has to go to this device first, then the next file. There is a order management in it, right? We cannot do with a load native config or load, right? And another thing is basically no isolation of device state or the config failures. If there are any failures, right? If I'm applying all 10 files together to 5 devices in the load native config, I cannot isolate the failures, right? Let's assume that one of the device is not reachable, the whole entire transaction will fail, right? What we are trying to do basically, we are isolating those failures, and whichever the device is available and whichever config is right, we are going to apply and report failures at the end, right? With
Thanks,
this,
thanks,
I will hand it off to Karthik. Thank you.
Thanks, Grisha, for briefing up the drawbacks and the solution of it. So let me go through the history of when this started and how it started. So basically, the idea started from TMO, so where the journey started from 4G and then followed till 5G cups. So the major idea was to push the configurations on an ad hoc basis. The reason behind that, the time till now, I think 5G is new to everyone, be it in RAN side or be it in core side or be it in edge cloud side. Everyone are evolving as they are progressing it, and everyone are learning and relearning the mistakes and everything. New services are getting in. That's where all this idea popped up, where we need to have a generic config audit where we can push the configs on multiple devices in a single go and easy to track. That's where the whole idea started, and then it has been evolved as a journey, and we have supporting devices like SMF, UPF, SMI, CEE, and also we have adhered to RCM based deployment of Cisco. So all this part has been available in the mobility functional pack, which we have generalized the mobility functional pack, which can be reused. And currently, we also been tested this on number of numeric CLI and Netconf devices, be with different vendors. So, and Garisha will be followed by a demo. He'll be showing different vendors communication. And then we have this currently available as a MVP now, and it can be easily consumable. And please reach out to us if you need further more details on the MVP and other stuff. With that, I'll just brief what exactly the generic MOP configuration is all about, and what all it supports on a minimal futuristic part of it. So currently as this MOP generation, right, has been asynchronous in nature. It's not exactly MOP generation, MOP configuration. It's asynchronous in nature, where you can fire the request and forget, and please track the status. and then the rollbacks of it. So there are three NSO actions on by default we have developed. One is for pushing the MOP configurations, and one fetching the status, and if required, if you want to roll back the MOP configurations which is previously pushed. And then we have a support to multiple config files in case where you want to push multiple config files one by one. You can orderize your request and push the configurations accordingly. And then you have a rollback of a mechanism for the configurations which you have pushed. We have complete complex combinations are supported. For example, you have pushed config file 1 to device 1 or file 2 to device 2, and you need to selectively roll back only the file 1 of a particular device will still support. So all those combinations of rollbacks has been supported here. And as Girisha mentioned, this provides you a device state and configuration file. What, for example, you are going to push a configuration for 10 devices and couple of devices are not in reach, or configurations are not properly booted up, or day zero is not properly applied, then those devices configurations will not be pushed and it will be pushed to other devices. That's the beauty of this. So it doesn't fail the transaction, but it fails the status of the device. This I see here you can see what are the basic packages which we have developed. So we have developed predominantly 3 packages. One is device onboarding, where it's predominantly required to see what are the devices which has been onboarded. And another one is the config metadata, and another is the generic config map. So config metadata is very much required where you want to push the dynamic configurations. For example, you want to push a peer IP on multiple devices. So the peer IP will vary from device to device. So these kind of configurations we can globally define based on the device, and then generic config map package has an inbuilt intelligence to pick up the config metadata according to the device and configure the devices accordingly. So this is the feature which is very much required when you want to push the similar set of configurations but changing the values. And the generic config map is nothing but 3 actions which we have developed, which does the core business logic of it. So this supports ICSR kind of map push or RCM based redundancy group map push. So multiple variants has been supported accordingly. So what is in roadmap? So the future roadmap for this enhancement, right? So we need to have a single transaction across the device and across the files. Now currently we have transaction at device level and files level. So you can have a transaction either push all the files into the device, or you roll back all the files into the device, or you can push single file into the device, and if the other config files fail, let it be failing. That's the support we have, but we need to enhance so that entire whatever the request has to be passed, let it pass. Other if it is fail, let it fail. So that is the one of the corner scenarios where user may requires. So we need to enhance on that. Then support to integration of customer CIQ data. So this is what I'm saying. This is very much important for config metadata, where we can integrate with CIQ data and pull all the relevant data of that infrastructure of the devices, so which can be reused in pushing the configurations. That's the another enhancement we are planning to do. And then web UI interface. Currently, these packages are all worked on the free source REST clients. So we need to have a web interfaces for this to invoke and track all the historical MOP requests, so that user knows if there is any request he has fired, what he has fired, what is the data he has fired, and then what is the rollback file it generated. And he can always go back and see if you want to roll back those particular requests, he can do it. So we'll have a single point of glass where all the details with respect to requests and the rollback files will be available. Yeah. With that, we'll just move on to the demo part of it.
Quickly jump into the demo. Right. In our NSO, we have loaded the packages. These first 5 packages are net packages, and next 3 packages are related to the MOP, config MOP, right? And I onboarded some of the NetSim devices, right? Belongs to iOS, XR, StarOS, and JunoOS. We onboarded a different set of devices to showcase both the CLI as well as the Netconf device. JunoOS is a Netconf here, and StarOS is most likely virtual device, right? And iOS and XR mostly physical device. We wanted to show all the combinations. That's why we choose on this set, right? I just wanted to showcase what are the configurations, CLI configurations which we are trying to push, right? We go to the files. This is the iOS content, right? I'm creating Gigabit Ethernet 02 interface. Likewise, I'm creating another interface with 03. These are all the two iOS files, right? Likewise, iOS XR, there's a single file and I have a variable defined in it, right? Description, right? I define this description in the config metadata so that it chooses according to the devices. Likewise, we have a genoise. Again, I'm creating one more interface and I have a star OS text, which is actually creating in APN context, right? These are all the files. We are actually getting an analogy wherein which these device files belongs to a single service, and basically we are trying to push it together, right? Let me get back into the REST-conf interface, right? So we have three actions, right? This is a config action, right? Which we use it for doing the commit or the dry run of set of files to the set of devices. And this is actually a status one, right? Since it's asynchronous, we get in a task ID wherein which we can monitor with the task ID, right? What is the status, right? This is a rollback one, right? This is an example with the partial rollback, right? We are rolling back only set of files to set of devices, right? So let's get into the config metadata update first. What I am doing here for the iOS XR, the first device and the second device, the description I'm defining based on the device name, right? Let me send this. It got succeeded, right? Then I make in a request. If you look at it, operation type could be a dry run or commit, right? I am committing directly. And the MOP type could be common or pair. In the pair case, it is actually pushing both active and standby devices. It pushes to the standby devices first and basically the active device next. And we have a MOP type for standby only, right? And if you provide set of devices here, which determines which are all the standby devices and basically push the configurations. Likewise, active only, right? There are some more types which is custom, right? These are all the generic MOP types available, right? If you look at it, the MOP file names, we have a Genoas file pushing into the Juniper single device and iOS XR file pushing into two different devices, iOS XR 1 and 2 devices, right? Likewise, if you look at it, there is an order also mentioned here, right? This has to be pushed first before this, right? If you don't mention the order, this is optional, right? NSO takes its own order, right? The MOP takes its own order to push it, right? Likewise, I am pushing this file into this. If you look at if you remember, there is a description variable in it. It has to push two different description to two different devices. Likewise, iOS JSON file I'm pushing into the iOS 1 and second device. The iOS 2 is same. I am keeping the different order there, and basically the star OS as a order 3, and I am pushing the star OS configurations to star OS. So in order to showcase the mimic the failures, right? Actually, I brought down the iOS 0 device, right? It has to report in a failure, right? Let me push this configuration, right? So I get a new task ID, right? Each and every attempt is actually bring in the new task ID. This could be changed, right? Right now we are using the hexadecimal, which is unique, right? According to the project need, we can change this task ID, right? I have to monitor that because this is a synchronous call. I immediately got the task ID. In the background, it is working, right? So if I click the send button, it's completed state already, right? Since they are the NetSIM devices, it is pushing fast. If you look at it, iOS device is actually not reachable. That's where this is in the failed state, right? The iOS 1 is basically the complete state. If you look at it, we are actually isolating the push, right? There are failures in the iOS 0 device. Because of that reason, we are not pushing it, but it is not stopping us to push it other devices. If you look at it, all the dry run files and MOP files are created. These dry run, basically the rollback files are used as and when you are actually trying to roll back, right? iOS 2 devices which is pushed, right? We have also keep track the commit QID which is generated by NSO, right? If you look at it, it's completed for all other devices except Cisco iOS 0, right? Then we'll go back and see the folder which is actually generated based on the task ID, right? Which is actually generating the dry run files and basically the rollback files according to the files plus devices, right? If you go to the iOS 1, in fact, you look at 4 files, right? 2 commit files, and because we are pushing 2 different files and 2 rollback files, right? Likewise, iOS 6.1, we look at it, commit, CD and commit file, which actually shows what exactly is pushed. If you look at it, this is actually replaced with the config, the metadata, right? Likewise, there will be a rollback file, right? That actually says how exactly the rollback looks like, right? This is a reverse diff generated by NSO, right? We are actually, in fact, using the NSO APIs to generate the reverse diff, right? We are storing it here. Okay, all right. This is what the structure looks like, right? You come back. So we have to use the same task ID, right, to do the rollback, right? There's a correlation ID. This is actually in the payload wherein which we can do the partial rollback, right? I wanted to take out the iOS XR content from the iOS XR 0 device and iOS 2 file from the iOS 1 device, right? So I just wanted to do the partial rollback. I can do that. I do the send, then I will get in a different task ID altogether. Go back here, check the status of that rollback. This is in a completed state. It's taken out the content, right, which is actually generated the rollback of the rollback, right, in the different task ID now, right? Then it's taken out from only 2. If you want to do the full rollback, you just give the task ID, and operation type could be commit or a dry run, right? So based on that, it's basically it works, right? If you say dry run, it doesn't push it to the device. It generates all the commit files and the rollback files, right? This is a quick demo, right? That's all we have.
Terrific.
Okay.
So do you have any final words? Do you want to conclude, or is...
Yeah.
Yeah, we are good. I think we are open for the questions.
Yeah, open for the questions. If I'll request, feel free to ask questions, or you can reach out to us for any further queries or further enhancements or whatever. You can reach out to Girisha or myself, so that we can definitely help offline as well to get more inputs from the customer side of it as well.
Okay.
Thanks, and please open for question and answer.
Yeah, I think we need to move on. We're tight on the agenda. So thank you, guys.
Thank you. Thank you, everyone.
Thank you.